Hello, everyone. This is Jim the Builders, and we will be presenting our final presentation. Our members consist of Jadarius Lawson, Luna Muhammad, and myself, Emmanuel Martinez. And next, I'm going to talk about the outline for our presentation. So first, we're going to start with a bit of background on our project. Then Jadarius will cover the specifications, constraints, and standards. Then I'll speak about the concept and design development for our project. Next, Muna will talk about the project management. And then all three of us will give our input on our testing for the project. And then I will conclude with the changes to the project and our future work in conclusion. So in the next slide, I'll talk about the background. So we wanted to do a project that was more software than hardware. Since we have two computer engineering majors, Jadarius and myself, and one electrical engineering major, Muna Muhammad. And we also wanted to make a device that could help a certain demographic. So we looked into making a device that would help nonverbal children with autism, as I myself have a brother that struggles with autism. And next, Jadarius will discuss the specifications.
Hello everyone, it's your Darius Lawson, and I'll be going over the next three slides. And for our specification for our device, we wanted to be the device that was easily accessible for children with a 7x4 touchscreen interface. And we designed it to have power capabilities of 2.5 amps of current. The operating system was Python and through the Raspberry Pi. And the memory capacity was one gigabyte of RAM, and our speaker was the LED Sound Crystal 3-watt. Okay, here's our constraints. Sustainability was vital for the construction and continuous development of our device throughout the semester. In order to maintain a place of relevance in reference to similar devices within the marketplace, going forward, we have to continue to monitor the constant involvement of technology to ensure the position that we designed our device to have within the marketplace. Manufacturability, we wanted to have a device that was easy to reproduce and design multiple devices in an appropriate time frame that would allow us to satisfy the demand of our marketplace. But we also wanted our device to be unique in the same sense, so that you couldn't find another device with the same capabilities. We desired to build a device that a company would want to purchase from us or sponsor and provide device manufacturing. That's the next one. And here are a few of our standards. Information and data flow was essential because all electronic devices have to maintain and develop data in order to function properly. Because technology is constantly evolving, and constructing such a device requires repetitive communication and researching device capabilities while applying them to further the use of our device. The standard for establishment of health and safety for all prospective users is very important to us as a brand, because no user will want to use our device if it is a health or safety risk. In terms of from a marketability standpoint, no company will want to sponsor us for that same reason. We designed our device to have no risk for electrical shock failure, no interference risk, or power supply short circuiting. And next slide.
So for our project, we knew we wanted to use a microcontroller, so we compared the most well-known kinds and settled on the Raspberry Pi, as it was capable of doing what we wanted to do for our project. We also chose to program in Python, as the Pi is mainly programmed with that language. We also used 3D printing for the housing because we had access to it on campus and wanted to make a custom design fit for children. We also kept in mind the cost and portability for the device, as we wanted to make it inexpensive and portable enough for the users to take it anywhere with them, such as schools and the playground. Next, I will discuss the level 2 decomp. So for the level 2 decomposition, the signal will start by booting up the system via a button like most tablets. Next, input will be read via touch because the tablet does have a touchscreen, and this will be sent to the data processor. In the data processor, input will be made as text or images that will then be converted. In the text to voice module, it takes in this text and converts it into speech. And finally, output will come out as speech, and the user can input as many words, phrases, and pictures to convert as well. In the next slide, Mona will discuss the project management side of the project.
Great. Hello, everyone. I am Muna Mohammed, and I will be discussing the project management aspect of our project. So for making decisions and communicating, we scheduled continuous Zoom meetings. We met at least 2 or 3 times a week on Zoom, and these meetings pretty much we discussed. We were able to agree on goals and create like a Gantt chart, establish tasks to be completed by each group member and tasks to complete together. Discuss and assist in resolving problems whenever it arose. If someone had a difficulty with a specific section, this is the time we can ask questions and see how we can best resolve the issue. And also agreeing on the completion of the project. So this was time to like set deadlines and kind of communicating to see who was lagging and what, and how we can set the time frame based on so everybody can get everything done at the same time. Outside of meetings on Zooms, we communicated via text. So we have a group text that we can easily access anytime. So anytime someone needs to share information or needs a meeting to be set up, they can message in that text message and we will make that accommodation. And then to share information, we created a Google shared file and we were able to edit stuff together at the same time, as well as kind of upload things for another person to look at. Moving forward, each person's contribution in the project, I am Muhammad, so I was the lead and the spokesperson of the team, and I pretty much focused on the hardware components. I was in charge of ordering the parts, as well as constructing the hardware to make sure that it was usable so they can go ahead and upload the application version. Jadarius Lawson was our scribe and auditor. He was in charge of pretty much communications, as well as kind of combining all of our cost tracking information together. And he was also in charge of the interface and the image module for our project. Emmanuel Martinez is our analyst. He was pretty much the person we went to for like decision making sometimes. And then he pretty much focused on the phrase and the word module in the application version. So I worked on the hardware component on my own, and then Jadarius Lawson and Emmanuel together worked on the application. For planning and setting goals, we created a Gantt chart, as you can see over here. We split it up in like 4 phases. We did have to make adjustments to this in the middle of our semester because we were lagging behind. But we just pretty much created a phase 1, which allowed us to do some research and kind of get everything ready for our project. And then phase 2 was focused on pretty much the ordering parts and starting the application and everything. And then phase 3 was construction of the device, as well as testing of the different modules. And then phase 4 was like putting everything together to get it ready for the end. For short-term goals, we had an individual outline created for each person. So each person was asked to create like a 10-week outline of things that they know they can complete on a weekly basis to make sure they can meet the deadlines, which were the long-term goals. So that pretty much was how we set goals and planned for our project. For cost tracking and time tracking, for time tracking, as you can see, the pie chart over here splits up on assignments that we focused on and spent most of our time on. Individual work is the main one we spent the most time on because each person was assigned a specific task and they could work individually on it. There were times that we had group meetings and we could combine ideas, but most of the time we each had our own individual work, so we spent a lot of time doing that. We also spent a lot of time researching. I personally don't have much experience with dealing with people with autism, so I needed a little more research and went through YouTube as well as reading a bunch of articles to kind of prepare myself to create the best device that could be used by anyone in that case. And it was the same for my group members as well. We wanted just to get a little more background into the group that we're dealing with. For group meetings, we met a fair amount of times, and then we focused on class assignments as well. We worked on those together, and then we took a lot of time planning. We did spend a little bit of time testing, but we'll talk about that later as well. For our material cost, we estimated cost for about $300 last semester. We didn't want to go above that because we wanted to make everything minimum cost. But as the situation we're in right now, it wasn't really convenient for me to go on campus and just utilize the stuff at school because of the schedule restrictions. So I had to buy things that were more convenient to use at home to help me construct my device. So that's why our budget kind of went up above the expected. All right, and then testing. We have a little video over here that I can play in a moment. But for the hardware component, we make sure to test the durability, portability, and the tablet functionality. So the durability was measured by doing a bunch of drop tests and kicking the device around. Portability was just the addition to the device to help it be easily taken from one place to another by a child or a young adult. And then the tablet functionality was just to measure how the speed of power on, to make sure that the touchscreen works properly, as well as being usable so that Emmanuel and Jadarius can go ahead and upload their software on there. I'll let Emmanuel and Jadarius speak about the software first before we show the video.
So I was in charge of the text-to-speech converter, and I tested the text-to-speech with the Raspberry Pi. The program worked fine on the computer, but when I went to integrate the software onto the Raspberry Pi, there were some issues with the pronunciation of certain words. Certain words were being pronounced in other languages, but I was eventually able to resolve this issue. Also, while testing the text-to-speech, I tested the external speaker on the Pi at different volumes just to make sure that the sound was coming out clear. Next, Jadarius will speak about his part of the testing for the image and interface modules.
On the module image interface and testing throughout the semester, I used multiple integration techniques to develop a successful module that works in conjunction with Emmanuel's speech, phrase, coding as well. For the final test and up to this point, I completed the drop-down menu user selection module as well as the image display for each category associated with whatever the user chooses to say, like I want this or I like this, and etc. And now Mona will play her video of her testing.
All right, so what you're looking at over here is me doing a bunch of tests. So I have a little tape measure that helps me measure the distance in which I'm dropping the devices, and which I did for 1 feet, 3 feet, and about 6 feet. And I also spent some time kicking it over here to make sure that it's durable for like young kids, because this is what you imagine a young kid would do, would just leave it on the floor and they would kick it. Over here, I'm adding the strap so that it can be portable, and when you shake it, like a child can use it if they're playing on the playground or moving in a very fast pace or something. The string can be adjusted, and it can also be removed easily, as you can see here, if no one wants to use it. All right. There's also an addition in the back where you can hold it in your hand. And I found this to be easy to use because you can just have it there and type whatever you want instead of having to hold it across your chest. And in this portion, I am testing the boot up time. So as I kind of clicked on the on button and I went ahead and started the timer. I'm going to kind of fast forward here because I know how long it's going to take. And as you can see here, it took about 24 seconds to boot up, which is pretty good. And as we continue, I am like testing the touchscreen capabilities. If I touch something, it responds and it kind of comes on. I did have the Wi-Fi connected to my computer, so I went ahead and just went to like an internet page. And you can see when I'm scrolling, it's responding pretty well. So the touchscreen components are working properly. I was doing more testing over there too. And then as we move on a little bit later, I'm testing the sound with the speaker. And you can see I'm closer. And then as I move farther away from the tablet, you can still hear it pretty well. All right, that's the hardware testing component. I'm gonna go ahead and share the PowerPoint one more time so Emmanuel can go ahead and give us the last part of the presentation.
Thank you, Mona. For the conclusion of our project, unfortunately, we ran into issues with integration with the Raspberry Pi, and we're not able to complete all of the modules for our project. But we would like to still continue testing and debugging our device for the future, as well as adding more durability to the housing, as we don't want to make it so it breaks easily, as we do want to cater this device for young children as well. And this concludes our presentation. Hope you enjoyed. Thank you.